Good day to all. In advance, my thanks to the Faculty of Law of the University of Wroclaw for the invitation to this symposium of the study of writing, and especially to the Professor Rafał Chisler and the scientific committee. My report is an analysis of some peculiar features of Wacom's signature scope software. The analysis of the software signature scope of Wacom was performed using the package that was provided me free of charge for study purposes. The graphometric software in question, designed, produced, and sold by Wacom, allow users to affix an advanced electronic signature onto a special Wacom tablet as regulated by the regulation EU, EIDAS, and so on. In carrying out this analysis work, the operating instruction of Wacom manual, user guide, were followed after being downloaded directly from the signature scope taskbar by pressing the Help button, following them as closely as possible, including the knowledge gained by software with its use thereof for education purposes. In the present case, tablet STU 530 Wacom was used to specify that other Wacom tablets could be used that has not some limitation in capturing certain dynamic data of the signature, as well see below, such as TU 500, DTU 1031, and so on. Devices used to affix the graphometric signature must, however, be able to detect at least the main parameters: position, time, pressure, speed, generation on the user's signature. The parameters that characterize such operation are the sampling frequency, the resolution in equations, the curve that represents the graphic path of the signature along the x-axis, and that of the y-axis, acquired by the tablet, the captured pressures values, the active area, the pixel size. The software operates with Windows 7, Mac OS 11, and successive of both. Signature scope takes advantage of the ability of Wacom software to store data while capturing the signature exactly as they were provided by the device. Each data group, for example, pen position, signature times, pen pressure, etc., is collected with metric information that employ the drives used by the device. This information is stored with point data to enable conversion to SI units where required. The advantage of this method is the accuracy of the information that is determined by the device and cannot be compromised by the conversion process. In addition to pen data, Wacom signature capture software ensures that contextual data is collected and stored with your signature. The additional data includes the name of signatory, date and time of signatory, the reason for it, and so on, and the type of hash and data used for document by C, and so on. Once it is loaded, the software appears this screen on the PC display by clicking on the signature button. A drop-down menu drops, and you have to click on Capture. The STU530 tablet became operational, and the tablet display appears on the screen on which various functions are listed. First, in the upper left corner, you will see the following words: acquisition of the signature, while under the baseline where the signature is to be affixed, the words unknown signatory. Otherwise, if the tablet was already enabled to name, the name of the subscriber will appear below it, including the time and date. Finally, at the bottom of the tablet, you will notice that following three buttons: OK, delete, cancel. Once you have affixed the signature and pressed OK, the signature will be captured together with all its data. It is possible now to examine the signature on static form, as well we'll see later. The deleted cancel button of the taskbar allow you to delete the signature should you desire. Once the signatures are loaded, you can start the analysis by clicking on the bottom of the View button of the taskbar. Doing so will cause a drop-down menu to open containing various types of tools to analyze different functions of the signature data captured during its affixing onto the tablet, namely file information, signature images, capture details, digest matrix, pen data, dynamics, display, time graph measure graphs. I will now describe and make a brief introduction of the function that, in my opinion, are peculiar among those that software allow us to get. All tablets should be equipped, among other things, with a camera that captures the posture of the signature while affixing the signature, as this would allow to record, in addition to the movements due to agonist and antagonist muscles and adduction and abduction of the arm. Also, the movement of supination, pronation, palmar flexion, dorsal flexion, torsion of the hand. All these affect the position of the pen drive during the execution of the graphic layout of the signature, and which infer in the rotation and in the moment of the graphic path, clockwise and counterclockwise. For questions on brevity, only some of the signatoscope software instruments will be described in this report because, in my opinion, this constitutes a quick plurals compared to other graphometric software that have been the subject of our analysis, analyzed, and that at present a special feature of the software and analysis. By clicking on signature image, we will be able to see the static signatures, even if in non-original dimensions, that we have collected, and we will put them vertically or horizontally, clicking on window in the taskbar, and then on arrange in the drop-down menu, in order to better analyze the graph following the morphology and the ballistic of the examined signature. After opening the drop-down menu by clicking on View, in the taskbar, click on Time Graph. A window opens with buttons showing graphs of pressure, speed, direction, azimuth, height, altitude. By clicking on direction, a graph appears. The graph shows the direction of a pen's movement during writing. This movement increases if made in a counterclockwise manner, and decreases when made in a clockwise manner. The movement of the pen drawing the graph is expressed with a line passing from 0 to 6.28 radians. It has making a complete turn of 360 degrees, assuming that a radian corresponds to an angle subtended by an arc equal to the radius. Since the circumference is 2r pi approximately. On round angle correspond to the angle underlying an arc of 6.28 times the radius, and vice versa. The two buttons, azimuth and altitude, may be analyzed only if you use a metric tab or vacuum to collect the appropriate signature. In this case, the three-dimensional data expressed by the algorithm in the two angles, azimuth, the angle between the vertical to the plane, z-axis in a system of three-dimensional Cartesian axis, and the pen. Altitude, angle of the plane on which is affixed the signature, x and y axis of the Cartesian axis, and the pen itself as it held by the drafter, as you can see better in the following illustration. In summary, the black arrow is the p-axis, which represents the inclination of the pen relative to the plane and the azimuth. Therefore, in the adjacent figure of the pen, and the green marked angle between that arrow and the red arrow, representing the z-axis, is the upper angle seen from above, or the azimuth, and is measured in degrees. The other angles between the p-axis and the x-axis, that is the lower blue color, is measured in radians and represent the measure of the inclination of the pen on the horizontal plane. The green arrow, starting from the point 0, finally represents the y-axis. Another function that is peculiar in that of the signature measures. They are normalized signature data in order to be able to compare them with those of the older other signatures collected in comparison according to the normalization formula expressed as follows: that I equal parentheses x I minus n parentheses / sigma. Always in the view button, when it is opened the drop down, you could click on signature measures and the following window will appear. It contains a whole series of normalized data of writing that are systematically compared. In this case, we have 4 signatures, C1, 2, 3, 4, in comparison. It contains, obviously, apart of the strokes, a whole series of normalized data of the writings that are systematically compared. The data are measured in different units, depending on whether they are in linear measurement or in time. The data are indicated with the appropriate unit of measure of the size to which they refer. Example, length is in micron. Micron equal 1 millionth of a meter equal meter to 10 minus 6 times in thousand of a second. 1 second equal second to 10 minus 3, etc. You can then, by clicking on measures, graphs, highlight the graphs of each single measure above and compare the scripts under examination and comparison only to a time, as you can see from the graph beside, which represent the curves of 2 scripts in analysis and comparison regarding the T contact. The contact time between the tip of the pen and the display, measured in milliseconds. The lines in red represents the writing in question, and in blue, one of the comparative collections. Their values will vary from time to time in linear units measurement. Conclusion. The graphometric signature allows the scientific study of the captured data of the signature performed by the CD pen drive on the graphometric tablet. Beware of easy enthusiasm towards technology that does not act, it cannot act automatically and anonymously. The primary concept of these new technologies lies in excessive trust placed by the user in a not yet mature system, which may not have yet considered all the variables associated with handwriting, and there are many, together with the other variable of the online subscription, which have not been subjected to adequate experimentation. So say Heidi Erasson in her book, we are in fact in the field of the objective, subjective, graphic variability. They can give life to the CD false negatives that is not first recognition in dynamic elements of the signature of the writing subject. It is difficult to find a perfect software on the market. The continual research and the comparison between software allow to highlight the critical points and look for solution for the correct analysis of graphometric signatures. It should always be remembered that the system of data detection of the graphic line, whether static or graphmetric, are not infallible. They may be inherent defects to this system, and also for objective modification of the organs or behaviors recorder. The research of software signature scope Wacom, granted free of charge by Wacom, exclusively for study purposes, was conducted jointly by Riccardo Recchioni, advocate, criminalist, forensic and writing expert in analysis and comparison of graphometric signatures, and Dr. Claudio Calzolari, astronomical physicist by Alma Mater Studiorum University. Thank you for your attention.